Being a ham operator isn't always rainbows and unicorns. And that's because we often need to do maintenance on the gear we put up in the air. In today's video, I'm going to be doing some maintenance. About 8 years ago, I installed this tower assembly, my poles, my tilt-over mast, and this thing's been rock solid for me. It's been a great performer. However, it's needed a few things fixed. My 80-meter dipole, one leg of it, broke off of my Fan Dipole assembly. And I need to fix it, and I need to take some other stuff off the pole. I've had a number of pieces of gear on this mast over the years. Mesh for ham radio, also my cell phone antenna booster, and a J-pole antenna for 2 meter, 70 centimeter. When you embark on setting up a tilt-over mast like this one, it's 40 feet tall. There are a lot of things to consider to safely put this up. One thing you want to consider is the top of this pole has a I wouldn't say a waterproofing, but the top of this mast, you've got one of these caps on. You'll see this on older homes where your utilities come into the home. It's so that the water has a way to drain off your cabling before it goes down the mast. This tilt-up pole is hollow all the way down. And that means water is going to drain right out the bottom of this thing. And that's good. Now, the majority of my feed lines going up this tilt-up pole is heliax. Only because of the time I found some, it was cheap and easy to put up. It is a lot of hassle. It's very stiff and rigid. It's not very flexible. You can see here, it's almost like having conduit on your pole. You don't need it for HF, but I do have it on there for VHF. This is where the first repair happens. My 80-meter dipole, this leg broke off. What it's supposed to look like is this. And so now it's time to do some maintenance. I'm going to cut this off, put some new wraps on here, solder it down, and that should last me for a few more years. Now this HF antenna that I'm showing you here is the Fan Dipole. It started out as a 40-meter dipole, and we grew this thing to be 10, 20, 40, and 80 meters. And 15 meters, of course, with a tuner. I'll put a link in the description below, but you can't tell with the labeling here. This is an alpha delta center insulator made for just this purpose. And you can loosen and screw these nuts off of these bolts and add more wires to get more bands. Now in my configuration, I'm doing an inverted V because I got 40 feet of height and my yard is not wide enough from side to side. Those are one of the compromises that you have with an antenna like this. Having a safe setup is an important thing to consider when you're designing an antenna mast like this, or a pole, or some sort of form of getting an antenna up in the air. This 40-foot mast goes from about here where I'm standing all the way out to my shed. And the purpose of this design, why I didn't go any higher, is if this thing were to fall, the way that it's mounted in this carriage where these poles go, this thing only has one place to go, and that's that way. So what that means, if this thing were to fail and land out in the yard, it's not going into my neighbor's yard, it's going to land on my own property. And that's an important consideration. If you're unfamiliar with waterproofing and coax seals, one of the most important things you need to do for the HF connections, or any connection really, this happens to be my cell phone booster antenna. It's a really ugly looking thing right here because often that's how that is. But this is watertight. Nothing's going to get into that thing as far as moisture. And that's going to keep those connections brand new. Now down here at the Alpha Delta insulator, this thing has got, I'm just running some RG8 coax here as my feed line. That's all I need for HF. And I've got some coax seal that is covered on top by electrical tape. So when the electrical tape starts to fade and wear off, I know it's time to repair that, but yet the coax seal is solid and watertight down below. Now as far as for spreaders, they all merge at the top of the antenna. All your bands reach the top right here. If you've ever seen a design or plans for a Fan Dipole, now in order to make this easier for me to separate, once I put everything up and I've got all these wires hanging down, I just made a homemade spreader with some plastic. I think this is from a sprinkler head material, like a spike you put in the ground, because it's meant for outdoors. It can handle the UV. I figured it was going to be strong enough. And this has been up a good 4 years and they're still going strong. So we're going to need for this fix a few basic tools. We're going to need some needle nose pliers, some bigger ones, a pair of dikes to cut the copper weld that I'm using, some sort of crescent wrench or wrench that you might have to fit the front of my center insulator. And in this case, I'm using a butane soldering iron. This is going to help me solder this connection on the end to give us that strain relief connection to make it stronger. Getting the old broken piece off is going to be easy. A couple of snips in certain places here are going to get the old copper weld off and be able to pull off the other connections to get to the piece that's broken off. So now I've got the remaining piece that was already existing for my other half of the dipole. I'm going to use that because only a few inches got cut off, and really feet make the difference in changing frequency on 80 meters. And so we're going to take another, 8 inches or so, wrap this around here into the center insulator, and then I'm going to be taking the dikes, and this is really stiff if you've never used copper weld before. I'm going to wrap a couple of turns around the copper weld on the outside, tighten it, and bring it back around to the front. So once I've made my first loop, my first 2 sets of loops around the center insulator to get this copper weld onto the extension piece, that's going to be my strain relief. I want enough copper weld wire to get back to the center insulator so I can bend it around and make a loop again using the dikes, and that's going to fit right around here on the center insulator. And in the end we're going to screw that down, tighten it all together, and it's going to work fine. Now I can attach the other bands back onto it with their connectors and then tighten it all back down. Double check both sides so that you can make sure that the thing is tight before you put this back up. And the last part for making this strain relief be acceptable for me is I'm going to use some solder. We're going to solder this connection, not necessarily for an electrical connection, but just so that it doesn't move around. So this thing's not going to move, and it's going to give it the strength that it needs for that thing not to rub on itself. Now it always pays to check your gear before you started, and when I started using this butane torch, well, it ran out of gas, so I couldn't even get the thing started. And now my backup plan is using a standard soldering iron, and I drag out the extension cords to get this thing set up. It's on high power, as high as it will go, because the wind's blowing, and that's going to keep cooling off the tool. And I want to make sure this thing is as hot as it can be to get the solder onto the copper weld. So this fix went pretty easy. It was pretty simple to get this done. Now you can see I've taken off all the other stuff. I took off my mesh node that was on here, and I took off the J-pole that I had farther down the line because it was just adding extra weight, and I don't need those antennas like I used to have use for them before. So fix number 1 is good to go. So this is going to make my mast assembly an awful lot lighter, kind of like it used to be in the beginning. So in a way, I'm kind of going back to basics. But I've got 2 different sleeve poles. They're going in here a good couple feet and then bolted in place. And that's what's holding this together. I put some coax seal up on top of there to keep this fitting from rusting and weakening the steel. Now this is a galvanized steel pipe, so it's not like you can weld to this really easy. And plus, I just don't have a welder. I'm trying to do everything like from the store. Off-the-shelf kind of parts to get this thing put together. Now I did have my stand-up assembly there. That was welded in specific places to keep this thing where it needs to be. Over the years I found that it just got harder and harder for me to lift this thing up in the air. So a couple years back I mounted a winch on here. This is an ATV winch made for an all-terrain vehicle, like a quad or something like that. And this time I powered this winch with the Redodo 100 amp hour battery, and it didn't even flinch. Now I'm interested in showing you one of these features that I'll call it a feature because I needed to do that to keep the birds from messing on top of the pole onto the patio. And so what I did is I took tie wraps up here and this extension bracket, which this extension bracket actually keeps the center insulator a good foot away from the mast. So when this thing's standing straight up, it's a foot away, so I'm not going to get as much interaction, if any. But the birds were standing on here, and the only way to get rid of them, if I turn you this way, was to put something on to keep them up. Now the little birds, they obviously just stand on here and they really could care less. Matter of fact, even some of the big birds do. But it does keep some birds away, and it's a cheap, affordable way to make that happen. Now here's another feature that I put onto this, or accessory I put onto the top of this mast. I've got myself a pulley up here, and this is riveted down actually onto the pole. And what I use this for is if I have a test antenna that I want to get up in the air and, I don't want to use a tree or something, I can use this rope system to pull up a test antenna and try it out by different configurations. And I use this rope. I've got about 90 feet of rope for pulling up spare antennas. Just gives me that added flexibility. This gives me a 40-foot mast that I can attach to. For part 2, check this video out right here, and I'll see you next time. 7-3.